Hey, what's up, guys? Just another video to keep collecting the fact in that computational complexity because I recently I'm learning it. Okay, so I have a video list about some computational complexity fact that or some proof that I collect, and I will keep going to collect it. Okay. So this video is just proving a simple fact, which NP is a subset of PP, because I think it's pretty interesting. So I want to make a small video. Okay, so recall that the language L is in PP, right? If only if there is a probabilistic Turing machine, a Turing machine that's called M, such that okay, so the first one is M runs in polytime. Okay, so let's say L is a right, L belongs to PP means that a given instance there's the input length of X is n, so it runs in poly n. And the second one is that if X belongs to L, then this probability machine the outputs the probability that it accept is greater than strictly greater than half. So probability that M accept or the same as M output 1, then outputs 1 is greater than half. Okay, and the third one is that if X not belongs to L, then probability that M accept or M output 1 need to let's say equal to half. Yeah, so you can define this to be this, but sometimes your equal sign should be fine. Okay, and I think everyone knows NPs, so we can only in general, if you want to prove this kind of thing, you only need to like do an NP complete problem. Right, so idea is that given a Boolean circuit or the Boolean formula, and you can ask whether there's a solution or not. So where there's a x such that f of x equals to 1. Okay, you can also define NP to be the class, right? Like for example, there's let me just quickly review, right? So you could define NP to be if x belongs to L, then there is a verifier. So V is a polynomial verifier. Okay, so let me just I should write as this. So a class L in NP, basically the requirement is that there is a Turing machine that's called V. Okay, for given X belongs to L, and there is a Y, this is called the witness or certificate, such that V, X, Y accept, and the V need to run in polytime. Okay, and also this Y need to have the polynomial size of X, right? So Y need to have Okay, so Y need to like have poly size. At most have poly size X. So given instance, right, you can find a poly size witness, and you can also have a polynomial time algorithm that run this and accept. If X do not belongs to L, then for all witness, right, then such that the V of X need to output reject, or V of X Y output 0. Okay. But in principle, that you can imagine that you're just doing with some Boolean circuit. Okay, so the fact that we are going to prove non-trivially probably is NP subset of PP, and you can use the same proof that which I will talk in a future video. You can prove that BQP is a bounded quantum polynomial time is also subset of PP, and the idea is the idea is the same. Okay, so idea is similar. So the idea is that you randomly guess, and you make a flip, the bit flip, and you slightly turn this bit flip speed slightly higher than half, then you can get the results. Okay, so the algorithm. So let's do this. So given let's consider Boolean circuit. Okay, and we want to show that the NP is a subset of PP. Okay, so we run algorithm, we define algorithm, which is PP probabilistic algorithm. We do in the following step. So step 1 is that we random guess the solution. Yes, X belongs to 0, 1 to the n, and the check f of X is 1. Okay, or not. Okay, if is 1, then our algorithm M just output 1. Okay, so M just accept and accept. Okay, and otherwise means that f of x is 0, then N do the strictly weird thing, right? So M outputs, so then M outputs 1 with probability less than half, but less than a little bit. So less than half minus 1. Half minus 1 divided by 2 to the n plus 1, and output 0 with half plus this. Okay, so this is our algorithm. So we need to check that this algorithm is true. Okay, so basically we want to check that. So we need to check if f has solution. Basically, f has solution. Then the Turing machine accept with probability strictly greater than half. If not, we need to show that the probability of M reject or needs also that greater than half. Okay, we need to show this. Show this fact, right? Because then we prove that MP is a subset of PP, right? Because we prove that given the Boolean circuit and or Boolean formula, and this PP machine can solve this problem. Can really like solve this problem. Okay. Yeah. So I think this one is simple, right? So obviously that if if there's a no solution, right, then M always output 0 with probability higher than half. Should be true, right? But you need to think, okay, yeah. So in this case, that always true, and right, because if there is a no solution, right, then M always output 0. But the M output 0 will probably half plus half divided by M plus 1. Okay, but how about if M has solution? Right, but sorry, if F has solution, that means that the probability that the probability, right, that you first come up with 1 is at least 1 over 2 to the n. So F has a solution, then the probability the first guess that you're correct is at least 1 over 2 to the n. So the probability that you guess right is at least 1 over 2 to the n. Okay, so that means the probability M accept is 1 over 2 to n, right? At least greater or equal to times the 1, right? Or the sorry, it's not 1. It's not 1. This one is not important. So it's half 1 divided by 2 to n plus. That means that suppose you're like suck, right? So you suck, right? You didn't find a solution, but with the probability less than this. Okay, right? This is the probability that this is the probability that you didn't find the solution. This is the probability that the M outputs the wrong solution. Okay, and right, so you can check this. So it's half plus 1 divided by 2 to n plus 1. Okay, the amazing thing is that if you expand it, you get this part, and then this part will cancel with this part, and then you get this. Right, you can have minus these two, and you get something like this. Okay. Okay, yeah. So this guy is exactly like greater than half. Okay. So that means that if this formula has a solution that output with the probability greater than half, if it no solution, that it output it reject, right? Eject or reject less than the reject probability is also strictly greater than half. Okay, so yeah, so this proves that this MP is a subset of PP. Basically, one can use this proof to prove that PP, I mean PQP is subset of PP. See you guys in next videos.